Now, in this video, we're going to consider one more problem on a cylindrical cylinder, a steel rod. So, here, the problem number 67, a steel rod of 4 meter long and 20 mm diameter is subjected to an axial tensile load of 40 kilonewton. Determine the change in length, the diameter, and volume of rod. So, take E equals 2 into 10 to the power of 5 Newton per mm square, and Poisson's ratio equals 1.25. So since it is a steel rod, here he has given the diameter, which is 20 mm, and the length is 4 meter long, so 4000 mm. And the diameter is 20, and then the load which is given to be 40 kilonewton, which is P is 40 into 10 to the power of 3 Newton. Then they determine the change in length, what is the delta L, and delta D, and the volume of the rod, and take E equals 2 into 10 to the power of 5 Newton per mm square, and also Poisson's ratio 1 by m, which is equal to 0.25. So here first we will need to find the change in length, and first we will go into what is the original volume of this original volume. What is the cylinder volume of a cylinder, which is pi d square by 4 into L. So where we know the diameter, which is given to be 20, and also the length is known, so we will going to get the original volume. So that is pi by 4 into 20 square into 4000 divided by 4 will going to give you calculation. You are going to get 125,637.06 mm cube. Once you get the original volume, so now we will going to find what is the change in length. So we know delta L, but we don't know the value of stress. So we know the load and also the length, and we know the area of cross section into Young's modulus. So P is 40 into 10 to the power of 3 into L, that is the length of the member, which is 4000 mm, divided by area is pi d square by 4, which is pi into 20 square by 4 into Young's modulus is 2 into 10 to the power of 5. So on simplification, you are going to get the change in length as 2.5465 mm, which is increase in length, because it has been applied with the tensile load. Since it is along the length of the member, therefore naturally there will be increase in length. So that is the reason why we are getting increase. The load is applied along the length of the rod, which is of 4 meter long. Therefore, there will be an increase in length, but there will be a decrease in the lateral dimension, which is the diameter. So what is the longitudinal strain? Longitudinal strain is nothing but delta L by L. So we know the delta L and we know the length. Therefore, we are going to get the longitudinal strain directly. That is 2.5465. Substitute this value of delta L here, and we know the length of the member is 4000, which is given in the problem. So therefore, you are going to get it as, on simplification, you are going to get it as 6.3662 into 10 to the power of minus 4. Now we need to find out what should be the lateral dimension. So we know that the Poisson's ratio, it is the ratio of lateral dimension to the longitudinal strain. So, but we know 1 by m and we know the longitudinal strain, therefore we are going to get the lateral strain. So to do that, epsilon lateral will be equal to 1 by m into longitudinal strain. So 1 by m is 0.25, which is the Poisson's ratio, and the longitudinal strain is given by 6.3662 into 10 to the power of minus 4. You substitute the epsilon longitudinal value here, therefore you are going to get the lateral strain as 1.592 into 10 to the power of minus 4. Since it is a strain, it is a unitless. So, but also we know what is the lateral dimension here. Since it is a cylinder, so you are going to get only the diameter. So the lateral strain is the ratio of change in diameter to the original diameter, which is delta D by D. So we know the lateral strain, which is 1.592 into 10 to the power of minus 4. We substitute the value equals delta D, which we don't know, but diameter is 20. So you are going to get delta D by 20. So on multiplication, we are going to get delta D will be equal to 3.184 into 10 to the power of minus 3 mm. So since it is the load is applied along the length of the member. Therefore, the lateral dimension will going to decrease. That is the diameter. There will be a decrease in diameter. So that is the reason why you are getting decrease here. Then what we want to find out? We want to find out the volumetric strain, which is delta V by V, or epsilon V will be equal to epsilon x into 1 minus 2 by m. So we know what is epsilon x, that is the longitudinal strain along the x-axis. So that will be 6.3662 into 10 to the power of minus 4 into 1 minus 2 into what is 1 by m, which is 0.25. So you substitute these values. On calculation, you will going to get this volumetric strain as 3.1831 into 10 to the power of minus 4. Once you get this value, so then we have the volumetric strain epsilon V will be equal to change in volume by the original volume. So you know the volumetric strain, you know the original volume. So change in volume you will be able to get, that is delta V by V. So therefore delta V will be equal to epsilon V into original volume. What is epsilon V? Which is 3.1831 into 10 to the power of minus 4 into the original volume is 125.6637.06. So on calculation, you will going to get change in volume, that is delta V will be equal to 400 mm cube, which will going to be the increase in volume. So this is how you will be able to find the volumetric strain, the change in volume, and the dimensions of a steel rod. Thank you.